Hi, so good morning. We are going to discuss six problems about finding the limits of certain quotient of functions where we get an indeterminate form upon substitution. There are a variety of ways to do this, and hopefully these six examples will show you some of them. All right, let's get started. Let me check. Okay, I think this is working. So we have our first problem. We want to find out what is the limit of the square root of 9 plus h minus 3 divided by h as h approaches 0. You will see here, okay, that if we do substitution, then you will get, by substitution, this should give you 9 plus 0 minus 3 over 0, which is, okay, square root of 9 plus 0 is 3 minus 3, that gives you 0 over 0. So, and this is indeterminate. This is a result that we um, do not want. Okay, so because the result is indeterminate, it means that we have to find another suitable function equivalent to the original function, 9 square root of 9 plus h minus 3 over h, but when we substitute, we will not get an indeterminate form. Okay, one way of doing this is to actually try if we could cancel the denominator h in this problem. And we'll try by multiplying the numerator by its conjugate. So I hope you remember your lesson in algebra about binomial conjugates. So the binomial conjugate of the numerator is 9 plus h plus 3 all over. To preserve the function, you'll have to multiply the denominator by 9 plus h plus 3. You will notice that this new function is equivalent to the old function. Okay. Just at this time, we have a factor, which is the binomial conjugate again of the numerator. And so this will give you, okay, 9 plus h minus 9 all over h square root of 9 plus h plus 3, which gives you h over h square root of 9 plus h plus 3. Okay, put that in parenthetics, which will give you finally, okay, we can cancel this. That gives you 1 all over the square root of 9 plus h plus 3. Okay. Now, what does this mean? This means that the original function square root of 9 plus h minus 3 all over h, as h approaches 0, since it is an indeterminate form, we could alternatively take instead the limit of an equivalent function, 1 all over square root of 9 plus h plus 3 as h approaches 0, because after all, they are equivalent functions. And fortunately, the convenience of this is that when we do substitution now, this will give us 1 all over the square root of 9 plus h, which is 9 plus 0, and therefore this is square root of 9 plus 3, or this is 1 all over 6. And there you go. The limit of the square root of 9 plus h minus 3 over h is equal to 1/6. Okay, and thus we have solved the problem. For this problem, I'd like you to take note of what we did, which is we multiplied the binomial conjugate of the numerator so that we can find an alternative function that is equivalent to the original function, and yet when we do substitution with the limit, we will reach a not indeterminate form. Okay. Now let's go to the second example. Right, we have the limit of 1 over x minus 1 over 3 divided by x minus 3 as x approaches 3. By substitution, we should get 1/3 minus 1/3 divided by 3 minus 3. And unfortunately, again, it will give us an indeterminate form. And because it is indeterminate, okay, we are told that we should find an equivalent function so that when we do substitution, we will not get 0 over 0. So our job is to first find an equivalent function to 1 over x minus 1/3 all over x minus 3. Now allow me to use this possibility. Okay, let's simplify the fraction because as it is, it looks complicated. Now to simplify this, okay, we know that the numerator can be um, put in compact form 3 minus x over 3x. Okay, that's for the numerator. And then the denominator remains to be x minus 3. Now, simplifying further, this should give us negative of x minus 3. Okay, so this numerator 3 minus x is equivalent to negative of x minus 3 divided by 3x x minus 3. Sir, I think I'm seeing the light at the end of the tunnel. Correct, because now we can cancel this. That gives us the equivalent function, negative 1 over 3x. Oh, so sir, this means that the limit of the original function, which was complicated, all over x minus 3 as x approaches 3, okay, is equal to the limit of an equivalent function, which is much simpler this time, negative 1 all over 3x as x approaches 3, which gives us conveniently negative 1 over 3 times 3, which is negative 1/9. And there you go. The limit of 1 over x minus 1/3 all over x minus 3 as x approaches 3 is negative 1/9. And there you have it. Okay, so this time, what did we do? In order for us to find the limit of an indeterminate form, we needed to find an equivalent expression by simplifying a complex fraction. okay, by simplifying a complex fraction. This is another method that you should try when finding the limit of an indeterminate form. Now let's move on to the third problem. We have another complicated fraction. Why? Because you have radicals on the denominator. Now, when we do substitution here, you will get the square root of 1 plus 0 minus the square root of 1 minus 0 divided by 0. That gives us 1 minus 1 all over 0, which is 0 over 0. Oops! Again, we reach an indeterminate form. And we don't like this, of course. So what do we do? This time, maybe we could try multiplying again the binomial conjugate of the numerator. So our mission is to first find an equivalent expression to this odd-looking function that when we substitute 0, we will not get an indeterminate form. All right, so let's give this a try. Square root of 1 plus t minus square root of 1 minus t. Let's multiply this with its binomial conjugate, which is 1 plus t plus square root 1 minus t divided by, and to preserve the fraction, we can just multiply the denominator with also the binomial conjugate 1 plus t plus square root 1 minus t. You'll notice that this is an equivalent function to the original, but with the added binomial conjugates on both the numerator and the denominator, which we of course know is just equal to 1. Right, so how would this be? Okay, this will be further simplifying 1 plus t minus 1 minus t divided by t square root of 1 plus t plus square root of 1 minus t, which is equal now to 1 plus t minus 1 plus t divided by the square root of t. Oh, by the way, I forgot to put parentheses here. All right, the parenthesis square root of 1 plus t plus square root of 1 minus t. And therefore, the numerator will now become 2t, all right, all over t square root of 1 plus t plus square root of 1 minus t. And, okay, further, we can simplify this by canceling t, which gives us, finally, you have 2 all over square root of 1 plus t plus square root of 1 minus t. And this, okay, so which means that the original function limit of square root 1 plus t minus square root 1 minus t all over t as t approaches 0 is equal to the limit of an equivalent function 2 over square root 1 plus t plus square root 1 minus t as t approaches 0. But what makes the second expression convenient is that when we do substitution, we will just get 2 divided by 1 plus 1, or we have 2 over 2 or 1. And there you have it. The limit of the original function square root of 1 plus t minus square root of 1 minus t divided by t as t approaches 0 is 1. All right, so we proceed to number 4. We have the limit of 4 minus square root of x divided by 16x minus x squared. Sir, how do we go over this? Okay, well, first is we do substitution. So 4 minus square root 16 divided by 16 times 16 minus 16 squared. Unfortunately, this is 0 over 0. Indeterminate again. So, what will happen? Perhaps we can do again multiplying the numerator by its binomial conjugate so that we can take out the radical and probably we can do some cancellation later on. Okay. So let's give it a try. 4 minus square root of x times 4 plus square root of x divided by 16x minus x squared and multiply that by 4 plus, square root x. Okay. Again, when we did this, we did not change the original function, okay, because we just multiplied it with 1. But okay, look at what could happen. Sir, that will give me 16 minus x, okay, divided by, okay, x, 16 minus x, I factored out x, and then 4 plus square root x. Wait, sir, I can do cancellation now, correct? You can cancel this and this, and you are left with 1 all over x times 4 plus square root x. Sir, this means that the limit of the original function 4 minus square root x all over 16x minus x squared as x approaches 16 can, or rather is equal to the limit of its equivalent function 1 over x 4 plus square root x as x approaches 16, which is, okay, when we do substitution now, 1 all over 16 times 4 plus square root of 16. This is equal to 1 all over 16 times 4 plus 4, or this is equal to 1 all over 16 times 8. which is 1 all over 128. And there you have it. Okay, so here, what happened? Okay, I'd just like to review what happened here. We did the usual, which is multiply a complicated fraction with the binomial of the binomial conjugate of the numerator, and then we did cancellation afterwards. Okay, and it was fruitful because we were able to reach at an answer that is no longer indeterminate. Okay, so let's go to problem number 5. Okay, so again, we have a complex fraction and the same thing. When we do substitution here, you will get 1 all over 0, 1 plus 0 minus 1 over 0. So here you will have 1 over 0 minus 1 over 0. Okay. Um, this is not 0. First, put it in your mind. This is not 0. Why? Because this is not a number, not a number. And likewise, this is also not a number. And therefore, you cannot subtract a not number from a not number. It doesn't make sense. Okay, so this means that this limit problem may be solved by using the same method as we did in the first 4 problems, which is to find an alternative function that is equivalent to this, but when we do substitution, will give us a meaningful number, not like this one. Right? So this is not an indeterminate form. It's just that this is a meaningless. This substitution will result in a meaningless operation. Okay, so what do we do? Let's try to find. Let's try to find an alternative function. All right. So how do we do that? Okay, we first simplify 1 all over t square root of 1 plus t minus 1 over t is equal to 1 over t, and then we have 1 over 1 plus square root of t minus 1. All right, now what's next? Now we know that this is just 1 over t, we leave that b, and then this one, the second one, can be taken as 1 minus square root of 1 plus t divided by square root 1 plus t. Sorry. Okay, so we just did the subtraction. But okay, and this again we will try. Probably, sir, we will multiply again the binomial conjugate of the numerator. Correct. Okay, so we have 1 all over. We just copy 1 over 1 t rather, and then we have 1 minus square root 1 plus t divided by square root 1 plus t. And this time we multiply the binomial conjugate of the numerator. 1 plus square root 1 plus t divided by 1 plus square root 1 plus t. Okay, so that's a parenthesis there. So this will give me copy 1 all over t times. Okay, now we have 1 minus, sorry, we have now 1 minus 1 plus t divided by square root 1 plus t times 1 1 plus square root 1 plus t. All right. Now, why are we excited? We should be excited. You know why? Because the numerator now is very simple. You have 1 all over t times negative t. All right? All over. Sorry. Mahaba pa kasi. Negative t all over square root 1 plus t times 1 plus square root 1 plus t. Okay, so let me just properly okay, thank you. Should be like this. Now, which means that yay, we could already take this out. So what does this mean? This means that the original problem limit of 1 all over t square root of 1 plus t minus 1 over t as t approaches 0 is just equal to the limit of negative 1 all over square root 1 plus t times 1 plus square root 1 plus t. All right, as t approaches 0, and there you see, when we do substitution here, we get negative 1 all over square root of 1, 1 times 1 plus square root of 1, 1, and we get negative 1 half. And there we have it. Yay! Okay, now what did we do here? Just a sort of review. We simplified a complicated looking fraction again by multiplying the binomial conjugate of the numerator, okay, until we got a proper solution. We go to the final number now. We have the limit of x plus h cubed minus x cubed over h as h approaches 0. And you know what will happen here. This will be x plus 0 cubed minus x cubed all over 0, which is 0 over 0. And something we don't like, unfortunately, it is indeterminate again. So what do? We find a suitable replacement to this original function. How do we find that? Okay, first I'd like you to recall the difference of two cubes. A cube minus b cube is equal to a minus b times a squared plus ab plus b squared. Okay, this is from your 8th grade algebra. All right, so sir, what's the relation? Well, here you go. A suitable replacement to the original function is to expand x plus h cubed minus x cubed over h into using this difference of two cubes. We expand this. This is now x plus h minus x. And then we have x plus h squared plus x plus h times x plus x squared. All right, all over h. We just did an expansion of a difference of two cubes. But it's very meaningful because now, if you take a look, this will become h over h times this long term x. Okay, I just transferred x plus h plus x squared. So this means that this original function can be replaced by this function. And why are we happy? Because again, we can take this out. Yay! Because we have taken that out, then it is now safe for us to do substitution. So the limit of x cubed minus, the limit of x minus h cubed minus x cubed all over h as h approaches 0 is equal to, okay, the limit of x plus h squared plus x plus h plus x squared as h approaches 0, which is conveniently now just x plus 0 squared plus x plus 0 plus x squared, which is x squared plus x squared, plus x squared, or that is 3x squared. And there you have it. Okay, now I'd just like to review what happened here. Here, we solved the limit problem, okay, by expanding the original function and then finding out that we can actually cancel with the expansion h and h. And because that is cancelled, now we arrive at an equivalent function, okay, that when we use substitution will give us a non or a not indeterminate form, or which will give us a proper limit. Okay, in this case, 3x squared. Now, also in this problem, I'd like you to notice that not all limit problems will result in a number. In this case, this limit problem resulted in an algebraic expression, in a monomial, 3x squared. Okay, so again, not all limit problems will result into a number. This particular problem, for example, gives a result which is a polynomial 3x squared. All right, so I hope with these 6 problems, you will be guided into solving similar types of problems, finding limits of indeterminate forms. There you have it. Thank you very much.